I am recording. So I am now recording. Today is March 29th, 2019. This is the regularly scheduled meeting of ITSE 2309 at Collin College. And I'm trying to get logged in. I am logged in. Okay, today we're working in module, what is it? Module, the data types. And I'm going to go ahead and get okay, and I want to talk today. I'm going to step outside of our realm today, and I'm going to step into the world of programming. And I guess it would help if well, I'm so flaky today. I've been here for an hour and a half. Okay, here we go. On and on. Okay, all implementations of SQL in and of itself is not very useful for much. SQL is a data pump. Writing a program in SQL in and of SQL in and of itself won't do very much at all, except serve up the data. It does that very, very well. So I wanted to talk here a little bit about the wrapper language. Every language, every implementation of SQL has built around it or has with it in some area a language. That language gives you things like variables. What we haven't seen in SQL, we haven't seen any kind of variables, and officially in this class you won't. That's the next class. We have seen, very briefly touched on, an if-then-else statement. If object ID, quote, table name, close, is not null, then, understood, drop table, table name. So that's if-then-else logic. We also would have a while loop, looping logic. I'm going to show you some of that today. We have things like print. So I can print stuff to the screen. I'm going to talk here a little briefly about the term print. I'm going to say print 13. Now, when you open a query, that query is a computer program. It's a program. That's kind of a rudimentary one, but it is a program. It's what we call a batch program. And if I just say, and I'm going to execute print 13 and watch what happens, well, it's going to print 13, obviously. Execute. And notice down here, I have the 13 printed. Now, let's compare that to what we would get if I said select 13. Notice the difference. If I say print 13, it just prints 13 into that screen area. If I say select 13, it returns a table with one row and one column, and in that cell is 13. Okay. So there's slightly differences between print and select. All right, let's talk about variables. Now, what we're talking about today, our main topic today, is talking about types, data types. Every variable in any program, well, not every one, but variables in computer programming languages have types. They're typed. Now, some languages are very loosely typed and some languages are strongly typed. An example of a loosely typed language is JavaScript. A variable is whatever you put into it. An example of a strongly typed language is the Java programming language. Java won't let you change anything about it. And SQL implementations tend to be strongly typed. What do I mean a type? When we talk about data types, what do we know about? Well, we've seen integers. What can fields be? Integers. What else? Character data, char or varchar, character data. Okay. Is there anything besides an integer?
A float.
A floating point, yes. So they could be a floating point. We call that in, well, float or real in database. Real has been superseded, so now we're calling them float or floating point. I don't know how many data places I've got, how many place values. It might, you're shaking your head, why not? What? Well, you don't think what? Well, we don't like, computer scientists do not like floating point. Well, I got news for you. Anytime that you're working with a circle or anything like that, you're going to have, or a degree, if you're talking about degrees, you have a factor of pi, and that pi is irrational, so you're stuck with a floating point value. And we don't like them. We'd rather not. Anytime I can get away from that, I'll always work with integers if I can, but floating point, well, we have them. And interest rates. You know, you have that E with an exponent floating around in there. And one other there, so we have integers, we have floating point, we have character data, we have another type, date time. The dates have times with them. A date, by the way, is an integer. I'll go into that in a little bit. I think I already have a little bit once. Some databases, some programming languages give you what is called a Boolean data type. SQL Server does not. SQL does not natively. Boolean is either true or false. Well, I don't really need one because I can implement it with an integer and I can make it be 0 for false and anything else is true. So that's, I can get around that pretty easily. But we have integers and we have floats. Let's talk about integers, okay? Anytime we have an integer, it has a maximum value. And you say from your math class, you know, Dr. Smith, you're crazy. Integers don't have a maximum value. Integers go on forever, right? Well, nothing in a computer goes on forever. It all has to end someplace. When we run out of memory, it ends. Now, the integer data type in a computer, in a database, and very typically in a computer, when you say an integer, you're allocating 4 bytes to that thing. 4 bytes. 4 bytes, there are 32 bits, 32 zeros and ones. Therefore, I can represent in that 4-byte space, I can represent 2 to the 32nd power different numbers. Okay. Start with all zeros and just start counting in binary until I get to all ones. So I start with 0 and I go up to 2 to the 32nd power minus 1. That's my space that I can number it in. Now, don't forget the zeros in there, and don't forget that you've got positive numbers and negative numbers, and the negative numbers are part of the deal there. So the biggest number that I can represent in an integer is 2 to the 31st power, because I have 32 bits. That would be 2 to the 32nd power. It's a little bit like if I have 3 bits, and they can be 0, 0, 0, 0, 0, 1, 0, 1, 0, and so on. With 3 bits, I can represent 2 to the 3rd power different numbers The biggest one I can represent is going to be 7. Although I have 8 different numbers, I've got to remember zeros in there. Okay. So the biggest number I can represent in a variable, well, I'm gonna back off of that for just a second, get back to it. Let's talk about integers. Here's an integer. This is how I declare an integer in this language. This language is called T-SQL. T-SQL, also you hear it called Transact SQL. Okay, this is the language that is wrapped around SQL in SQL Server. Now this particular class, ITSE 2309, is about pure SQL. TSQL is not pure SQL. TSQL is something added to it. SQL does not have a variable. Here is a variable. Oh my goodness, I have just declared a variable. What's the name of the variable? My int. And in this strange language, variables begin with, I guess that has a name. I've always called it the @ sign. Okay, that's what variable begin with. That's how I can tell that that is a local variable. What type is it? It's an integer. So its name is my int. Its type is an integer. You've probably seen this before. Some of you have had Java. Some of you have had C. They all have integers. Here's a float. Declare my float as float. Now my favorite thing to do is to forget to put that little @ sign on there. For those of you who are going to take the advanced class, you will see a lot more of this. For those of you who aren't, well, don't worry about it. I just needed to talk a little bit about a variable. And I can say set my int gets 13. Now it has the value of 13. It's going to keep that value of 13 until something comes along and changes it, like in line 18, it'll change. Or I hit a go statement. If I hit a go statement, it's wiped out. It doesn't exist anymore. Okay. So here's one, select, it's a little red there because I haven't said what database to use. I should have said up here, use and that'll get rid of that. Select, there's the variable, gets equals the vendor ID. In other words, take the value out of the database and put it into my int where the vendor name is equal to job track. And that stores that value. And now I can use that value later down the road in another SQL statement. Well, we haven't been able to do that before. I just wanted to briefly discuss this, and that it's really not that far ahead of us, a little bit ahead of us, but not far. And now I can have one SQL statement execute, and that can persist in my program being put into a variable, and then I can go back and get it out of that variable later. Questions? I can print it. If I printed it, this might not work. Yeah. Gonna execute that. I think I have to do all of these. And I believe that vendor name is 7. I believe no, it's 4. So the vendor ID for job track would be 4. Oh well. And when I hit go, they all go away. Question?
When you hit go, do you have any changes in the variable, or still having 4?
Variable goes away. Variable no longer exists. What's in the database stays, is persistent, but the variables that anything you said with declare no longer exists. When you hit the go, everything goes away. That's what Go is supposed to do. Now, Go is unique to SQL Server. If you go to another database, you won't find that. There'll be something similar to it, but you won't find that particular. Guess I can unroll my pant leg now. Okay, I'm going to show this demonstration now. This is an integer, and real is an old version of float that is more susceptible. So I'm going to talk about some things here. We're going to use a sum, and a real number is like a floating point. It has a decimal point. Don't know where it is in there. It's just in there someplace. So I have one integer here. I'm going to call it my count, and it is legal to assign it 0 to initialize it that way. My sum as real, it is usually considered good programming practice whenever you're putting a value into a floating point to have a decimal point. So if you want it to be 3, you say 3.0 instead of just 3. Just 3 would work. Okay. Now, line 31. What is that? You've seen it before. Do you know what that is? A loop. Nikki, have you seen that before? Okay, it's a while loop. While that's true, it's going to execute the body of that loop. So it's going to check and see, is my count less than 1 million in this case? Well, yeah, it's 0. So it's going to execute the body of the loop and then go back and check it again. While loops always behave that way. It's also known as a pretest loop. Every programming language you pick up will have one of those in it. No, you're asking, a question has been asked about the Java or C++ or C syntax of plus equal, stuff like that. Answer is no. This is not a terse language. This is, in fact, it's a very verbose language. It tends to get long and long-winded and lots of typing in it. So all of that stuff that you were expecting from C, all of those little shortcuts, not there. But everything that C does, well, everything, most of the things that C does, this language will also do. For example, you got a loop, you have if, then, else, you can set variables, and it executes in order. Now, we've seen that with SQL, it doesn't execute in order. That drives me nuts sometimes. But this is guaranteed to execute first. So that line 28 executes, then line 29 executes, then line 30 goes past it, 31, 32 starts, 33, 34, 35 in order, and goes back up and checks again and keeps staying right there. What do I do inside of this loop? Well, my sum is a floating point, real number, and my sum starts where? It starts at 0. What do I do? Each time through this loop, I'm going to go through 1,000,000 times. I'm going to add 0.01, in other words, 1 penny. I'm going to add a penny to that accumulator. When I finish, after going through that 1,000,000 times, 1,000,000 pennies, if I add up 1,000,000 pennies, what will I have? Well, I can get it by just knocking off 2 zeros here. If I add up 1,000,000 pennies, I'm going to have $10,000. Right? And then I add 1 to my count, and that's going to go through it 1,000,000 times. So when it hits 1,000,000, it stops. Well, didn't mean to do that. That's what I want.
Dr. Smith, is there a syntax with the indentions that has to be followed with this, or is this just
A syntax, it's pretty much an open format. Syntax question goes to, I guess the rest of you guys all heard that. Do we have to follow a particular indenting syntax? For example, the way the while loop is indented, is that what you're asking?
Yes, sir.
The answer is no, but it's certainly a good idea. I would follow the same syntax formatting rules or the same code formatting rules as you follow in other languages. There is no particular indenting works the same way as it does in C++ or Java. You tend to have whereas with Java, instead of begin, you would have a open bracket, and that open bracket would be paired with its closed bracket. I do the same thing with the begin end pairs in SQL. So when what we're going to talk about today then is casting, and this is coming from the, so print sum equals. Now what's that? Plus. Plus is the concatenation operator. So here I'm going back to what we're really doing today. Concatenate a string. So put it all together into one string. But notice that I have on one side of that plus, one side of the plus is the string, sum space equals space. On the other side of the string is an integer. No, excuse me, is a real, my sum. So I will always have some way with the language, every language has this, there is a way to say, change this value for now, for just this one statement, change it into something different. So when I say cast, and this is the word that's used all throughout computer science, cast it into something different for the purposes of this operation. So right now I want to hide the fact that my sum is a floating point number. I want to hide the fact that this is a floating point, because if I try to say sum is equal to and then plus my sum, what it's going to try to do, it's going to try to add them because a number is on one side, and plus when it's used with a number means add it, but when it's used with strings, it means concatenate it, put it together. Therefore, I have to take the right side of that expression and make it into a varchar. Okay, this says take that right side, make it into a varchar. Now, it doesn't change what this is. It's still a floating point number. But for the purposes of this expression, I want it to be changed into a varchar. That's what we're really talking about today. Plus, then I put some space in there. Count is equal to, and I cast my count, and I divide it by 100 as varchar. So this one, I'm definitely going to see 10,000. The question is here is, what will I see when I put this real number in there? And I'm going to go ahead and execute it. And it took it a while there. Did you see that little delay while it counted 1,000,000 times? TSQL is considered fairly slow by programming standards. SQL is much faster than TSQL. But let's look at what I got down here in the answers. Now notice that the count, where I said take the sum, that's 1,000,000. I'm adding up integers, and I just add up 1,000,000, and then when I divide that by 100, I get 10,000. By golly, by gosh, 10,000. It is always accurate. It will always be accurate. What happened over here with the sum? If I'm adding up pennies, and I add up 1,000,000 pennies, what happened here? I added 1,000,000 pennies, and I ended up with $9,865.22. Is that okay with you? No, not if you're an accountant. That's really, really bad. Okay. What has happened here has demonstrated the property of, it's called underflow. You get underflow when you are accumulating real numbers, or float will do it also. Float is less vulnerable to it, but it still happens. Anytime you have something that has a decimal place, anytime I have a number with a floating point where I don't know where the decimal point goes in that, it's just somewhere in there, and I'm adding up a bunch of them, particularly when I'm adding very small amounts and accumulating them, I'm going to be vulnerable to this area. Has anyone seen the movie Office Space? Everybody used to, oh, well, man, that was a funny movie. I guess I have to keep my examples up to speed. Any you guys online see the movie Office Space?
Yes, sir. Stealing pennies.
Go ahead.
Oh, in the code they were stealing pennies?
Yeah, they were stealing fractions of a penny. And so and that's very real, very, very real. And it's real because of what I'm just demonstrating right here. It's very common that a computer calculation will make a very, very tiny error in a decimal point calculation. It's not very common. It just happens all the time, because anytime I have a fraction like 1 penny, well, that's 1 over 100, it will not terminate in base 2. Yes, it will, only if the denominator is a power of 2. So for example, 1/8, 0.125 will terminate in base 2. But if you talk about 1/10, 1/10 cannot ever terminate in base 2. So I have this repeating decimal that goes on forever and ever and ever, but we know that nothing can go on forever and ever and ever, and sooner or later I have to chop it off. I've just introduced an error. And if I accumulate enough of those little bitty tiny errors, it can amount to, well, in this case, $135 over a period of $1 million. Go ahead, Juana. Yeah. Mm-hmm. But the point being that it's going to happen. Underflow is an insidious error. Underflow will kill you. When are you worried about underflow? When you're working with real numbers or floating point numbers. That's anything that is a circle where you have a sign in it, or anything that is compound interest compounded continuously, where you have that e to the x thing, and any of those real numbers that don't have any end to them. Anytime I have those, anytime I'm stuck with those, I'm going to have a problem. There was an early United States space shot back in the day before anybody else was shooting rockets into space. I remember it when I was a child. Early Mercury project, and it was the first one where a person in the spaceman went around the Earth more than once. So multiple orbits. And what happened, they had a little error. They had this kind of an error in there because they had pi in their computers. And when they finally got ready to bring the person back, the poor guy didn't even land in the right ocean because of this accumulated error. I forget which one that was, but he was way off target. And then they realized, oh, it makes a difference. Now there's methods that I can use for this. When I have fairly small numbers, so I can add up my pennies until I get $1 worth of pennies, and then I can treat that dollar as an integer and then add up the dollars, and I can eliminate most of the errors. There's things I can do that's beyond the scope of this class. But by the way, I just wanted to point out that anytime that you're dealing with a floating point, you are dealing with underflow. It happens all of the time. It is so small, it is very difficult to detect, but you can just kind of count on having it. Okay, look at the next one. The biggest integer I can have is 2 to the 31st power minus 1. This is very difficult for me to calculate and put in there. I happen to know the value of that it is 2,147,400, 2,147,000,000. 483,647, and that is 2 to the 31st power minus 1. That is the biggest positive number I can have, and in an integer. So if I were to put that number in there and then print it, it'll be fine. It prints. No problem. But what happens if I try to add 1 to it? I have a number that is too big for an integer. Now, what are my choices? What might the language do? Well, do you guys remember when a car's speedometer had 5 digits, that when it recorded your distance that you have driven? It used to have 5 digits. Anymore, this doesn't happen, so I guess it's some more of my examples going off. I'm going to have to retire soon because all of my examples have stopped working. But back in the old days, when a car hit 99,000 to 999, when it had 5 nines in there, what did it do?
Over.
Roll over.
Go ahead.
It rolled over. Started again.
Okay, we say it rolls over to 0. Now what happened there was your car really had 10,000 miles on it, but the odometer was showing 0 because it only had 5 digits. So what happens is it carried out of range. Now this is the phenomenon known as overflow. Well, overflow isn't quite as bad as underflow, and in fact, many languages will do that. Many languages will, when a program goes over, it will simply revert back to 0, or it reverts back to a negative number in many cases, the largest negative number, and there's a reason for that. In SQL, if I try to do that and I try to get it too big, what happens is I get an error message, and notice that it says overflow in the message. You can see it there, arithmetic overflow, converting to type int, meaning that I can't have an integer that's this big and add 1 to it. I can subtract 1 from it. I can start with one that's 2 to the 30th power and add 1 to it for another billion times, I guess. Anyway, a bunch of times. But I can't, if I take that number, that 2 billion something, which is the maximum integer it can be, notice one other thing. Well, I'm just going to tell you this kind of off the cuff. There is one larger negative number than there are positive numbers. It can, the negative numbers, it can go up 1 more than it can in the negative numbers. Why do negative numbers can be 1 number larger in magnitude than the largest positive number? Why do you think that is? Guesses?
It does not include the 0?
Because of the 0. A 0 is considered, is counted as, please don't go tell your math teacher that Dr. Smith said 0 was a positive number. Excuse me a minute. But it's counted with the positive numbers. It's a non-negative number. So there are the same number of negative numbers as there are non-negative numbers, and 0 is a non-negative number. Okay, that's fair enough. What else could we do? Well, SQL Server crashes. You get an error message. It doesn't crash, but I mean, it just gives you an error message, and I guess that's okay. At least it stops you from having the problem. Some languages will roll over. This one right here, we'll talk about a tiny int. There are different sizes of integers. Some integers can be larger than others. For example, a tiny int only has 1 byte, 8 bits. In 8 bits, how many different numbers can we have? Answer is 2 to the what power? 8 bits. 2 to the 8th power. If you figure it out, 2, 4, 8, 16, 32, 5, 64, 128, 64, 128, 256. 2 to the 8th power is 256. The largest, no, and there are no negative tiny ints because that would just be, what? Tiny int is just a number. If you want it negative, you got to remember it's negative. So 255. If I try to add 1 to the tiny int, I will again get an overflow. Okay. Let me see if I dare do this, and then we're going to take our break. Well, okay, I'm going to fire up a C compiler here. So don't everybody freak out because I'm going to run a little bit of C, and I'm going to show you this same kind of a problem, the way other programming languages handle it. What does SQL Server do? SQL Server just croaks. Well, I thought I had it there. Where is it? Are we going to run? There. Been a while since I've taught. Since I've taught C. In C, this is the C programming language. I'm going to talk just a little bit. That's power. POW, P-O-W, says 2 to the 31st power minus 1. So for an integer, that will be the greatest number, the greatest positive number that I can do. That's 2 to the 31st power minus 1. Now, it's not that easy to do that over an SQL, because what it tries to do 2 to the 31st power, figure out what that is. It gets an overflow right there before it ever does the minus 1. C doesn't suffer from that. So C does this just fine. And when C executes, it says I is equal to that 2 billion number. I'm just going to call it 2 billion. Then I'm going to add 1 to that number. Those are comments. And I'm going to execute this and see what we get. Notice that the first one, I, is 2,147,483,647. And that is what we were, that was the same number. That's I to the 31st power minus 1. And I added 1 to it. So someone was asking me what this was right here. I++. Wouldn't it be nice if they gave us that in SQL Server, but they don't. Well, that means set I equal I plus 1 is what that means in C. This is one of C and Java programmers love that one. And I would too, but I'm an SQL programmer. I don't have it. So where was it? Going back to this one, notice that when I added 1 to this number, when I got a number that was as big as it could possibly be, and I added 1 to it, I got the biggest possible negative number. Now that's interesting. Do you know what state in the United States, this is a geography test. Geography. What state is farthest east? It's a trick. It's a trick. Well, east, I agree with you. No, east is east. West is west. Never the twain shall meet. What state is farthest east? What state has farthest east longitude? The greatest east in terms of the longitude marked on the map. Maine is a good guess. It's wrong. What? No, I don't think you're close. It's Alaska. No. Everybody said, no, not Alaska. Why? Because Alaska goes into the eastern hemisphere. If you look at the 0 meridian, there are 18 islands out there on the Aleutian chain that are in the eastern hemisphere. They have east longitude. And this goes to the idea of why, when I get to the biggest number that I can possibly have, and I take one more step up, I end up all the way down. Because these guys are behaving just like they do. Right? I say, what happened to my, okay? It says go as far as you can go in that direction. Now I'm standing right on that dividing line and take one more step, and it's because there's a circular behavior in these numbers. The other thing I could have done here, I could have just thrown an error. That's what SQL is going to do, is it's going to throw an error. Other languages will not. Java programmers, are you a Java programmer? Do you program Java, sir?
No.
Okay.
I'm in C++, Python.
What does Python do when you overflow? Does it roll over? Okay. Many languages will. There are some that just stop doing anything and they just stay there. So if you add 1 to it, it just doesn't change. I don't like those. I want it to do one of the two, either throw an error or do what I'm expecting you to do. In other words, that's roll over. An integer in most languages can be unsigned. If it is unsigned, that means it can go all the way up to 2 to the 32nd power minus 1. So it has double the size, but it doesn't have any negative numbers. Okay, so this one is going to go up to 2 to the 32nd power. And when I execute this, this is 2 to the 32nd power minus 1. It is 4 billion. And if you just use 4 billion, that's pretty close. 4,294,967,295. And then I add 1 to it. And what do I get? I roll over to 0 because this one is unsigned. So when they're signed, it kind of shifts, and 0 becomes about the middle of it, and the ends of it loop around and they come together, is the best way I can explain it. There's a whole theory of mathematics on this, and I'm not going to try to get into all of that. Okay. If I were to do that exercise where I added the pennies in C, I would have a similar error over there. So if I added 1,000,000 pennies, I would expect to see about that same size of an error. That's just, they're going to happen. So all integers, this is the important part. This is what I want. This is your takeaway. All integers, I don't care how you represent them, whether you're writing them on paper or electromechanically or mechanical tumblers or a computer, all integers at some point will overflow. The only question is what happens when they do. Okay? SQL, you get an error. Other languages, it will roll over. It's still easily detected. All floating point will underflow. You will get this creepy little error in there. Okay? You just have to be aware of it. And anytime that you're adding up a bunch of very small numbers with floating point in them, be very careful. Okay, we're going to take a short break right now. And then I'm going to come back and I'm going to do char and varchar. I'm going to go pretty quickly through type char and type varchar. I want to talk about the type date, and I wanted to talk about casting. Okay, I'm done talking about, don't everybody freak out because I'm talking about programming. I do teach programming. Those of you who decide to, who haven't had all of the SQL that they can handle yet and want to take the advanced class, we'll talk a lot more about programming. That's the last you're going to hear of the TSQL programming language from me, unless you want to do a week or something of it at the end as kind of a enrichment thing. I'd certainly work with that. There are other examples of the programs that are not the same. So once you get into those wrapper languages, you find that they are fairly different in syntax, but they all do the same things. Okay. I'm going to, how's my voice? Am I still recording? Well, they're talking to me, so I guess I am. Okay, let's see. I'm going to pause the recording.
Back for the last week's quiz where it just came up blank.
Yes, I think that has been fixed. Give it a look-see, and if it is still blank, let me know.
Okay.
And I'll fix. I'm not going to get my knickers in a big knot over it. Right now, I'm just getting this up and running. Probably will be for this class. So for this class, but in the future, I'm going to implement it for sure. So today's color. What is today's color? Today's color is purple for the recording. Purple. So anybody listening to me can write it down, and anybody who hears this in the recording, it is purple is the answer. Usually I won't be that. So you could answer it now, and it will have the YouTube link in there. Okay. What? The what now? If you are in the face-to-face class, I don't think you will see today's quiz yet. I'll get it up there. What? Okay, I didn't think you would be able to, but we'll get it up there. But the answer is still going to be purple. And if it isn't, send me not a nasty, just let me know what's going on with it. I can't always see it the same way you do, which is kind of confusing for lots of people. Okay. Previous one is duplicated. Okay.
Twice. I answered it, and then I noticed apparently I didn't answer it, so I
Well, they're the same time, and
only to notice that apparently the assignment showed up twice.
okay.
So I don't know what the issue is there.
Well, well, we're not going to get too upset about it. And then as I get it, because I pretty much have to put it out for the whole class and test it against the whole class. That means that we're just going to have some rough spots in it. It'll be okay. Well, purple. The one for last week was red, so this week's purple. All right, where were we? Okay, and I did. I noticed that I forgot to make some due dates, so I went ahead and put the due dates on there. But again, due dates are not a big deal on assignments. I guess I'm going to have to be more clear that when we're talking about a test coming in, that they are a little more. Okay, data types. We are in module 10. Intro. I talked, here is a page on the module about integers, and I talk about how big they can be, big int, small int, tiny int. This is typical. Double check my, okay, I am recording. As we move up, we double the number of bytes. So these guys get pretty big. A big int can be of 2 to the 63rd power. Well, 2 to the 63rd power is an awfully big number. I talk about overflow. Here is another one. Anything with a fixed decimal is an integer. Anything with a fixed decimal is an integer. Okay, if I fix the decimal, usually in money, we talk in 2 decimal places. Actually, believe it or not, money has 4 decimal places by international convention. If you are talking about money, it has 4 decimal places, and there are coins out there that are 1/10,000, excuse me, 4 decimal 10,000th of a dollar. In other words, it takes 100 of these coins to make a penny. Believe it or not, that coin exists somewhere and in the mint. They're not circulated. Why? Because you'd have to carry, they'd wear out your pockets and you'd only have a penny's worth of coins. So they're not worth carrying. If you are dealing in, if you are Japanese, a yen has 4 decimals to it. What is the currency denomination today in Vietnam? Is it still, what is it known as in Vietnam? Dong? There are 4 decimal places by international convention, so that everybody, even though you don't use them, in dollars we use 2. But unless you're buying gasoline, if you're buying gasoline, it's $3.15.9 or something. I'm aware of that they typically, have you ever seen it be 0.8 of a cent? Never. So, I mean, why do they do that? They don't have to. They could just, but I would never keep your pay as, let's say you're working and we agree on your rate of pay is going to be $15.32 an hour. Okay? I'm not going to pay you $15.32 an hour. I'm going to pay you $1,532 an hour because I want to get that decimal point out of it. And anytime I know exactly where that decimal point is, I can just shift it out, store it as an integer. When I store things as integers, I get out of that underflow problem. What's the underflow problem? That pesky little floating point error that I get in those things. Why? Because things that we think in base 10 are perfectly good fractions. When we go to base 2, they don't terminate. And that is a serious problem. Okay, anything with a fixed decimal is an integer. Here I talk about if I try to convert to binary, I would end up with a non-terminating decimal binary point. Eventually, I'm going to have to round it. So we fix it and make it an integer. Let's see. Decimal. There's some disagreement on how this is handled. The type of here is a number. This create table, this is a field. The field is known as a decimal. Sometimes you will see this represented as number, N-U-M-B-E-R. I think SQL Server will let you do it either way. What this says is, give me a number that is big enough to hold 8 characters, 8 digits, 8 digits. Give me a number that is big enough to hold 8 decimal digits. If it's got 8 decimal digits, that means it can have, that's up about 10 million, isn't it? It would have 1 followed by 7 zeros. So it's something like 10 million. And of these 8, 3 of them are to the right of the decimal point. What have I got here? That is an integer, even though it shows to you with 3 decimal places. It's an integer. It will not overflow. Excuse me, it will overflow. It will not underflow. You won't have any error in it if you add them up. Okay? You're not guaranteed that it cuts off at that high point, but it allows for 8 decimal digits, 8 base 10 digits. Therefore, I know that I have to go probably larger than that if I'm storing it in base 2, but I will have at least that many. The fee may contain 8 digits, 3 of which are always to the right of the decimal. And once you get that, nail it down, and you say always, that becomes an integer. We like integers. Then I go into how big is it. I'm not too worried about that. Money is always 8 bytes. Fixes the decimal at 4 places. So if you have money and you do some kind of division in there, you're going to end up with a 4-place decimal. That's okay. Yes, money is an integer. Next, I think I've about beat this one. Floating point or float. I talk here about some fractions. What is it that terminates and what doesn't? I'll let you take a look at those. The floating point decimal, most floating point decimals, floating points, will not terminate in binary. Means that you end up, if you think that a penny 0.01, 1 divided by 100, when you work it out in a decimal, it's fine. Nothing wrong. But when you take 1 divided by 100 and you represent it in binary and you do binary division, it does not terminate. And I can go into the reasons why. Say again? I'm sorry, I'm no, it doesn't. You just end up in a repeating decimal. It's like 1/3. 1/3. If I try to divide it out, 1 divided by 3, and I start dividing, I get 0.3333333333333333333. Okay. Some do, some don't, and the trick is I could go into it. It goes to the factors of the base. So 2 and 5 are the factors of 10. If the denominator has anything except factors of 2 and 5, it will not terminate. I think I talk about that here. In general, okay, this is what I want you to take away. Overflow, drastic error on the high side. It overflows on the high side. It carries out of range. It is a big error. Okay. whether your system crashes or not. Some do, some don't. You don't know whether it's, sometimes you have to check and make sure you have an overflow, but overflow is easy to detect. I add two positive numbers, I end up with a negative number. I take one step and I go from the Western Hemisphere and suddenly I find myself in the Eastern Hemisphere. Goodness gracious, something has changed. They move the international date line such that it doesn't go through the Aleutian Islands. So they put this jog in the, where today and tomorrow come together. Well, that's because that's, well, we can't have you throwing the newspaper into tomorrow, can we? Not really.
Something that we create.
Well, yeah, we had to decide where the date started, and you see some islands in the South Pacific will want to move from one day to the other because their mail comes from yesterday. Oh well, that's, I'm not worried about that. It's a similar idea. Okay, here we go. Character data. Character data. We are faced with two questions. Will we use only Western European characters? Will this, okay, ASCII. What does ASCII mean? This is not a test question. What does it mean? ASCII. What's the A stand for? Huh? ASCII, what? American Standard, AS, code for information interchange. It is 8 bits. 8 bits, the most numbers I can have, the most characters I can have are 255 characters. Well, that's okay. I mean, what, I got A through Z, that's 26, and capital and lowercase, that's what, 52, the digits and a few punctuations. I mean, I'm doing fine. It came as a big shock to us that there were other alphabets. This just really blew our mind that there were other alphabets, and that the Japanese alphabet and Vietnamese has different characters, and there are in the Spanish language there are different characters, ñes, and various characters that are different. And we ran out of characters. So finally, we had to go to the extended character set. But again, we're faced with two questions. The first one is, will we use only ASCII? Am I only in a world where everything here is going to be in the character set of the United States? That's seldom true anymore. Okay. Will we use the extended character sets? Do we support the Japanese, the Korean language, and all of their alphabets? Okay, that's the first question. And the second question we ask is, will our data have a fixed length or will it be varying? Okay, here's the two questions. Okay. So this one, the first column, trying to get a column here. The first column, this one, and let me see if I can do a control. No, it's not working. That column is fixed length versus varying length. Okay, char. If I make the field type a char, it will, if I say char 8, it will always have 8 characters. And if you don't use 8 characters, you don't have to use all 8 characters. If you only put 4 in there, it'll fill it up with spaces. It's okay. If you say varchar 8, then it can take up to 8 characters. Okay, but not over 8. And it will grow and shrink as needed. Which is better? Why do you say varchar? I mean, there's good arguments for both. Nikki, were you talking?
Yeah.
Did you say varchar? Okay.
Varchar.
Why varchar?
Varchar because it allows it's
Right. It's like an accordion. It can grow, it can shrink.
Probably I would think of varchar because you don't need to hold all the space
Okay.
like when you create a chart.
Okay. The observation is that if I don't use all of the characters, it can shrink down. So if I allow 8 characters for a name and my name is only Joe, I'm only using 3 characters, I can reclaim that 5. Guys online have any observations there? Anybody?
Would it affect your storage size when you're storing all
It does affect your storage size, yes. I mean, if I have a field that can take up to 8 characters, but I only put 3 in there, I'm only storing 3 characters. Okay, here's the rub. Nothing in computers is free. Nothing is free. There's a cost to everything you do. There's a big cost to making things variable size. When you think about it, the thing I like to have in a database is a known size, so I can set everything out, lay it out nicely. When I have stuff that might grow and shrink at runtime, it's hard to build a house out of bricks if I don't know how big a brick is and can fix that. So a char lets you fix the size, and a char lets you be a whole lot, a char you gain a whole lot in terms of the complexity of doing things. So if you can stick to char, my rule of thumb when I'm doing a production database, if I'm under 64 characters, I'm always going to go with char, even though it might grow and shrink a little bit. So we want to allow 64 characters for an address, say. I'm going to, but it might not be that. I wouldn't ever make that a varchar. It might be a very short address, but I'm going to make it 64 character char field. I'm going to lock it in at 64 and just, okay, I'm going to waste a little bit of space there, but I'm going to get the benefit of not having to grow and shrink. So the I tend to like char over varchar. Now, if I've got something really big, I would use a varchar field for if I were setting up a hospital database and I wanted to have a place to put doctor's notes. I don't know how much the doctor's going to write. Okay? They might write just a little bit. They might write, saw the patient, doing good. Saw the patient, he's dead. Mr. Kurtz, he dead. So I don't know. So I'd probably make that varchar. But in terms of a name or a title or something like that, I'm going to always go with char, take the biggest name. And for example, a person's name, if a person has over 16 characters in their name, they're probably used to it being chopped off. Is that right?
What is the cost?
The cost? The cost is that to grow and shrink, everything around it has to grow and shrink. You know, consider a house built of brick. And you take one of the bricks in the middle of that wall and you make it be a 1/4 inch longer. Think of the problems that that's going to cause as it grows, and then you have it shrinking and that leaves a hole. So it causes a lot of runtime problems when it grows and shrinks. The other thing that it can do, what they'll typically do with it, they'll store it someplace else. And so for char, they'll store it right all together. But when you have a varchar, they keep an address and then they go someplace else in memory to get it, or on the disk to get it. I like char.
Running versus space.
Right, right. You're correct, Juanita. You're talking about there. It's always a trade-off. So char costs you more in space. Varchar costs you more at runtime. Okay. As you go to the right there, we have nchar and nvarchar. Those are the extended character sets. We today will usually use nchar and nvarchar. I'm drawing a distinction between them. In my example database, I made mine char and varchar. In a real database where I didn't know what I was going to encounter later down the road, in terms of names, somebody's name might I might need to use the Chinese spelling. I'm going to go to nchar and nvarchar because this will include my Japanese alphabets, my Chinese alphabets, my Korean alphabets, Arabic letters. So I have and it's twice as big. Okay, so instead of 1 byte per character, I now have 2. So now I have over 16,000 different characters that I can represent. It makes quite a bit of difference. It's going to cost me. I put down here, once the decision is made to limit the character set, it will be very difficult to change later. So it's kind of like you always err on the side of caution. How big is a person's name? Well, I don't know, 16 characters, let's say. What if it gets more? How big is a social security number? 9 characters. We are going to run out of 9 characters. What? Yeah, well, we're going to have to do something because 9 characters, we're almost out. We can't reuse them because if someone dies, I cannot reuse their social security number because then if I have that social security number, I would be that person. And then I'd be dead, I guess, or they'd be alive. I don't know. So we can't reuse them. What we can do to get around it is we can have, we can go to characters. And that'll help us for a little while. A, B, C, D in there. But eventually we're going to run out. So when I were doing a social security, I would allocate more. So how many is it? 9, you say? I would allocate 16. Why would I allocate 16? Add some space. Why 16? Something special about that number. It's an allocation. It's the smallest allocation block, yes. It's a power of 2. I love powers of 2. 16, 2 to the 4th power. Now I'm going to go through, and then the next one I really like is 32. One I really like is 128. But oh, I talk about this, null and not null strings. If a field is null, then it has no value. If a field is null, it has no value. It's null. The string, single quote, is a value. Ooh, are you with me? It is possible to have a name that has no characters in it. It is possible, I have a name. My name is, it has no characters. But I have a name. That is not null. That is the string with no characters in it. So be kind of careful, be aware of this. The string, single quote, is a value. It's a string that has 0 characters. And I put a constraint here that we can check, constraint, last name null, check it's not null, and checks that the length is greater than 0. It has to have at least 1 character. I'm not gonna let you be. I don't know. Would does Cher's have a last name? Is that her last name or her first name? Is Cher, is that her last name or her first name? What's her last name? Oh, I mean, I don't care. I just,
I think that's just her name.
somebody on, just a minute, somebody's talking. Go ahead.
I think that's just her name. I don't think she sees it as a first or last name.
Right. So the question is, what do we do with that last name? I suppose that I would call it a last name and say you have to have a last name, but you don't have to have a first name. So I guess I'd call it, if you just had one name, I'd call it a last name. But basically, I need to avoid that problem of, if I say you have to have a name, you have to have a first name and a last name, am I going to allow you to have a first name that doesn't have any characters in it? That's not the same thing as not having one in database. Little problem there. If you go to Access and you create a field in Access, and I could show you this, and you say, okay, so it's the usual stuff. What kind of a field is it? You say it's a character field, and then how big can it be? I think they default to 50, I believe, or something. 50 characters is the default. And there's lots of other stuff, and can it be null? And that's a little checkbox that you make on it. You can't allow nulls, yes or no. Then there's one right under that. It says allow zero length. That's different from null. My problem is that if you check allow nulls no, then it asks you allow zero length, and that one defaults to yes unless you check it as no. It should default to no. Because if you're not going to allow nulls, you probably don't want zero length either. Something to think about. Databases in general, it's a problem in database in general. Down at the bottom, I say this matter causes us a great deal of trouble. Next, let me get through this. Sorry, did you have a question?
So I suppose, so the way that we would solve the problem of someone not having a surname would be to count their name as a last name?
You could do that.
Like what is the particular issue with having last name be an empty string and first name?
I don't see one. I could write a constraint that said check that it not. I can have an and in there, so check that the first name and the last name are not null. So that way, if you had one of them, it would work. It would get a little tricky to write, but it wouldn't. You could do it pretty easily. Right. The idea of null and a string of zero length are not the same thing. Okay, times and dates. These are pretty straightforward. Let me see where I can get to this. Okay. Date, the default format of a date. Default format of a date is, I guess I talk about that in here. I'm gonna come back to dates, I guess. I probably won't finish this today. Two types of, okay, data conversion. You saw me do data conversion a minute ago, right here. Data conversion. Okay, that is an explicit data conversion. I am explicitly saying, take this number, my count, take that number and convert it to a varchar. So that number might be 733. Convert that 733 to, quote, the character 7, the character 3, the character 3, for the purposes of this expression. Okay, cast. This is an explicit conversion. Um, value 1 it will do some, what? Say again?
Can you do the select? I'm sorry, I'm asking you.
You can do a select like this. Okay. If I have two fields, and one of the fields is, oh, let me go back over here and a new query, and let me go, I want to look at my Object Explorer. Do I have any? Let's see, I want to look at, let's look at vendors. Now, I've got some integers in here. For example, vendor ID is an integer. So if I were to go to my query, wherever it is, so I say select from and because I don't want to get points taken off of my query, I'm going to say use AP_DB. So when I get this, I'm going to see a whole bunch of numbers, 1 and so on. Okay. What would happen if I said select vendor ID times 10? Okay. Well, now I'm going to see 10, 20, 30. What would happen then, and I'm not sure this is going to work, what would happen if I said select vendor ID times the string 10? Now, I'm not sure this is going to work. I think it will. I think what will happen is it will convert, instead of times 10, I'm going to say plus 10. Plus 10. So it'd be 10, 10, 10, 20, 30, plus 10, 10, 2 plus 10 is 12, 13, okay? So let's see what happens when I do that. So 11, 12, 13, 14. So it's taking the vendor ID and adding 10 to it. Yet that's a string 10. Now, what would happen if I change that a little bit? And instead of that, I'm saying take it and put the 10 first. I should see the same thing. I'm not sure that I will. I do see the same thing, okay? Sometimes that'll change. Okay, so when I give it a string like that, and the string is a number, what SQL will do, it will do what they call implicit data conversion. In other words, it just says, well, you probably are trying to add 10 to it. Now, I do not care for it a whole lot when computer programs do this. It says you probably are going to add 10. But what would happen if I changed it? Instead of saying 10, I'm going to say foo. What will it do now? Well, it failed. Many times what it will do, it will say 1 foo, 2 foo, 3 foo. Okay. So implicit data conversion, it couldn't do it. This one, I'm going to say here, I'm going to say cast vendor ID as varchar. Now what will it do? When I execute it, it will just simply append the 10, because whatever it is, 1 gets cast as a char, and then it puts this other one on there. Now this one I can change to something different. Notice now it puts the XXX on there. Sometimes it will do implicit data conversion, sometimes not. In general, in computing, it is a bad idea to do implicit data conversion. You should do explicit. You should always cast it. So if I want it to be varchar, I should cast it. So this one is going to just stick a 1 0 on the end of everything. So when I execute 1 0, it just sticks 1 0 on the end of everything. If that's not what I want, if on the other hand I want it to be a number, even though if I did that, it's going to cast it implicitly, I should always say cast okay to say as int. Now it's going to add 10 instead of just tacking 10 onto the end. It adds 10 to the value. This is better. Now if I didn't say that, that's what it would do. But it is always better explicitly to cast your value. Let's see, where are we going here? Let me see where we're left with. Okay, there's our cast function. I'm going to talk more about these. We're going to have to spend a couple of days on this one. So I'm going to end it here on, what is that, page 5, 5A. Reading is that in the, let's see, in the module, I believe I give you a reading assignment. There's the PowerPoint lecture slides. There's your reading assignment, pages 240 to 260. And the PowerPoint slides are there. I'm not real big on the canned PowerPoint slides. Some teachers just really swear by them. Okay, I'm going to end there. I'm going to end our lecture and get that posted. And I'll get the quiz up for this class, the face-to-face class also. Hey, anybody, you guys that are online?
Yep. So Dr. Smith, I tried doing the quiz and I put in the answer that we talked about earlier, and it did not accept it. So
It didn't accept
accept it. Correct.
Oh, okay. Well, let me go check it. Go modules. I'll let you watch me. Go to here. No, that's, I need to go to the, $329. Edit. Questions. Favorite color. Details. It's saying the correct answer is purple.
Oh, there's 2 of them in there. That may be it.
There's 2 purples.
Is there? There's another one about midway down.
Yeah, but when I go to the, really? Okay, let me launch the student view here. Okay, well, like I say, we gotta work that out. Reset the student. Modules. Okay, let me see if I see 2 purples. Wish there was some way I didn't have to scroll all the way through this thing. Today. Take the quiz. Okay, there's a purple. Oh, there they, yeah, look at that. That's weird. Okay.
I think I just selected the wrong one.
Well, I know, but that, thank you for bringing that to my attention. Incorrect. I guess I selected the wrong one also. Okay, let me leave the student view and go up here since I'm here. Edit it. So I got 2 of them. No, I don't want to delete the question. Edit this question. Multiple choice. Purple, red. Okay, the correct answer is now purple. Update the question. Save. Now I'm going back to student view. Okay, now I just have 1 purple. Did I get it correct? Purple. Yeah, I think I got it. Do I? I haven't gotten it up for the face-to-face class yet. Okay. I'm going to go ahead and end the meeting right now. I will turn it back on. As soon as I end the meeting, it will start processing the recording so I can get it all up there before I go catch my train. So I'm going to end the meeting, leave student view.
Yep, and it works fine. I just double checked it. It works great.
Okay, so I got that one working, and then I'll clone that quiz over, and then we'll test to see if we've got it working on both classes. I can easily get it working on one, and then the other one doesn't work so well. Okay, so I'll get it up for the face-to-face class. Correct answer, it was purple. And so it's going to kind of be an attendance thing that I'm going to use to check attendance. And so even if you, okay. I am now ending the meeting. Okay, this is going to disconnect everybody. I will restart Zoom. So if you have any further questions, you'll be able to talk to me here in just a second. I'm going to have to boot Zoom to get this thing processing.